what we will do, how session synchronization and config synchronization happens. So we have already seen how the config sync happens. They will check the MD5 hash value and all. Now let's see how session synchronization is done by the Palo Alto devices. Even though, if you want to see, these are the captures I have taken, guys, and I have told you, right, they will communicate on port number. There is a one port number, so they will use ICMP. And because we have captured lots of traffic here, they will use port number 28769 for the communication purpose. Just remember, they are also using 28260. This is for some different purpose, guys, because your system daemon will also communicate between firewall 1 and firewall 2. If you want to see what are the basically what is the configuration they have synced with each other, let's see that detail as well. So let's follow the TCP stream, you will get to know. Let me just change this value. This is the configuration they have synced with each other, guys. This is the config synchronization they have done just now. We can capture everything, guys. Somewhere here you will get that particular test object, which is this one. Okay. This traffic is by 1.1.1, which is firewall, and towards 1.1.1.2, which is firewall 2. Let me just quit from here. Now, what is this session synchronization, guys? Because if you will see here, so right now, if I'll go into my firewall one, let me press here Control C. If I run this command, show session all, I don't have any session. On this device also, show session all, I don't have any session. If I'll run here one more command, show ARP. So ARP all, I have this particular ARP table, right? I will run this command here as well. So ARP all, I have this ARP table. I'm having same ARP table. Now let's do one thing. Let's go to into my topology here. Let me just open my router. Let me initiate some traffic from this router towards this switch. So what I will do, I'll go here. I'll just do the telnet on my outside switch, which is having IP 192.161.99. This IP address is there on this switch. Let's see. So if it is not working, that is okay. Looks like I have breaked something. If I run this command, show session all now, no active session right now. I'll go here into this device again. Let me just open this device, this switch as well. This is my inside switch. So IP route, let me just check. Okay, I don't have any route. So IP interface brief, all my interface in up state and my VLAN is in down state. VLAN 10, exit. Interface range gig 0x0/4 till 3. Switch port mode access. I have to configure this command. Switch port access VLAN 10. No shutdown. Exit. Now see, interface came up because that was the issue. Same issue I was thinking on this device as well. Looks like this. This is not active right now. So IP interface brief. Yep, it is also down state. Interface range gig 0x0 till 4 or 3. Switch port mode access. Switch port access VLAN 99. Exit. Do so IP route. Now you will see I have the route, right? So things are good now. Do right, ma'am. Let me just initiate the traffic now. Let's see. See, I got the access. Cisco is the username and password is also Cisco. Now, if I'll go here, you will see this session on both the devices. I have the telnet session here initiated by 10.1.1.100. It is going towards 192.161.1, right? This is the source port 63818. Go here, run the command here. So session all same initiated by this machine. Port is same, which means this is the same session, right? So what happens, guys? Your firewall, when they are running on active or active passive, they will do the config sync basically, or they will do the session synchronization, and they will do the session synchronization through your HA2 interface, guys. Just remember, they will do the session synchronization through your HA2 interface. That's why you can say Palo Alto supports the stateful failover, which means if this device went down due to any reason, you don't need to reinitiate that connection. That connection will relay through your firewall too as well. Okay, that's how they will do the session synchronization, guys. Apart from this, if you go here, if you run this command, so ARP all now, you will see some ARP, extra ARP as well, right? And you will get the same details here as well. Because they will do the ARP synchronization also, guys. Just remember. Okay. Now, let me just discuss what is heartbeat backup, guys. What is the use of heartbeat backup? So if you want to understand this heartbeat backup, let me cover what is a split brain in your Palo Alto firewall, basically. You will come across this particular thing, a split brain situation in your Palo Alto firewall. And let me just discuss that part, because they will ask you what is a split brain. And if you don't know the answer, which means they will consider you don't know the basic functionality of your firewall or basic functionality of high availability. So in a split brain, what happens? Let me just tell you one thing. Let's suppose we have here firewall 1. We have here firewall 2. Now, if you want to configure HA between this firewall, you have to configure HA1 interface, right? And you also need to configure HA2 interface, right? This is your control link. And this is your data link. Now, let's suppose here we have one of the switch. Here also I have one of the switch. I have my users here. This is my LAN environment. And this switch have a further connectivity with the internet service provider, ISPs. This is the right now setup I'm having. Now let's go into the basics. Basically, if you remember, I have mentioned through HA1 interface, they will exchange the keep alive messages. Keep alive messages, also known as your heartbeat messages, guys. What? They will exchange these heartbeat messages through HA1 interface. Now, why they will exchange these heartbeat messages? These heartbeat messages exchanged by firewall 1 towards firewall 2, and firewall 2 will forward towards firewall 1. They will exchange these heartbeat messages to tell each other, I am alive. Firewall 1 send to firewall 2, I am alive, and firewall 1 tell I am alive and I am in active state. This message firewall 1 will send. And firewall 2 will send, I am also alive and I am in passive state. And according to our configuration, let's say this is your active unit, this is your passive device. Now, let's take an example. I have here one PC. On this PC, default gateway is this particular IP address. This is Ethernet 1x1 interface. Let's suppose this Ethernet 1x2. And in your active passive unit, guys, we just have the IP address on active device. So let's suppose this interface have IP address 10.1.1.250. So let's 20. This IP address is fixed, guys, here. Okay. Now, so all the traffic from this machine is forwarded towards the firewall one, right? Towards the active unit. Now, let's see the example here. Let's suppose on our switch, we have F0x0, we have F0x1 and F0x3 or 2. Now on this switch, what he know? He know 10.1.1.250 is reachable via F0x0 interface, right? So because first traffic we will send to switch, and after the switch will forward towards the firewall. Now let's suppose, let's take an example here. Let's suppose due to any reason, this interface goes down. If this interface goes down, what will happen? Which means now your firewall 1 and firewall 2 will not able to exchange the heartbeat messages, right? If they will not able to exchange the heartbeat messages, which means your firewall 1 will not able to inform to firewall 2, I am active device, and firewall 2 also not able to inform to firewall 1, I am a passive device. That time what they will think, your firewall 1 thing, your firewall 2 is failed, is down right now. So what he will become active device, and your firewall 2 thing, firewall 1 is down. So what he will do, he will also become active unit. If both these devices, they will become the active, and right now this IP address 10.1.1.250 is active on this interface, and the same IP address is also active on this interface. Now this switch, he will get confused 10.1.1.250. Sometime he will get it is reachable by F0x0, sometime he will get it is reachable by F0x1, because both will send the GR, right? Both update the gratuitous ARP. He will also update the GR, right? Now, so what happens? This is the case where both unit is consider themselves as a active unit, guys. This is your split brain situation. A split brain situation, which means your both the firewalls will do the data forwarding, which means what will happen? Your first packet go here, second packet go here, first packet go here, then another one here, then here. So what will happen? Which means your packet is, all the packet is dropped. There is no proper synchronization, guys. So that is known as a split brain situation, guys. How we can solve the problem of this split brain? There is a one solution for that. What you can do, you can introduce one more interface between firewall 1 and firewall 2, and you can think this is your HA1 backup interface. Means configure the HA1 backup interface. So if your HA1 is in down state, your HA1 backup interface they will use for exchanging the heartbeat messages and hello messages. Now, one more thing. Let's suppose this HA1 backup is also went down. Your HA1 is down, HA1 backup is also down. Now, there's a one more solution. What you can do? You can connect the management connectivity. You can enable the heartbeat backup through your management interface as well. So through your management interface, they will only send the heartbeat messages, guys, nothing else. So that is your heartbeat backup thing, guys. That's how your heartbeat backup come in a picture, and it will basically solves the problem of your split brain situation in the network. Now, if you want to see how they will communicate with each other, right now I have enabled the heartbeat backup. So if I run this command, show netstat numeric, yes, match what I want to match 192.168.137.10. So you will see there is a one heartbeat backup connection is there, and there is a one raw connection is also created between firewall 1 and firewall 2. These are the management interface IPs, guys. This raw connection they will use for exchanging the ICMP messages or your heartbeat messages. Same thing is also there if you will run this command 1.1.1.1. You will see there is one raw connection is established between firewall 1 and firewall 2 through HA1 interface, right? This connection they will use for exchanging the heartbeat message. If you will go with 2.1, you will get one more raw connection here as well. So that's how they will communicate with each other, guys. Okay, now, so this is your split brain and this is your heartbeat backup. So we can use HA1 interface as a heartbeat backup, and also we can use management interface as a heartbeat backup. How you can enable? We can enable that feature if you will go into your device tab, into your high availability, general settings. Go here. Let me also go into this device because it's become slow. You will see this heartbeat backup, right? Right now it is grayed out because it's loading the settings. So here we have to enable the heartbeat backup option for management interface, guys. Okay. Now it's taking lots of time. So let's see. Now, meanwhile, let me just explain you what is preemption, guys, because they will ask what is the role of preemption in high availability environment, guys. So let me just take the help of one of the image here for preemption. So guys, in your Palo Alto Firewall, what happens? This preemption feature, what it will do? It will always make sure the device, let's suppose you have a firewall 1 and you have configured this firewall as an active device, which means you have a priority value is 50 on this device, let's suppose, and you have configured firewall 2 as a passive device where you have configured priority value which is 100. Let's take an example. If you have configured the priority values like that 50 and 100, which means your firewall 1 become the active and firewall 2 become the passive. So just remember, always just remember, if you will enable the preemption, so this preemption always makes sure if your firewall 1 is active or your firewall 1 is online or it is up and running, it will make sure it will always take the role of active device. Active device means it will become, or it will become the active unit always. It will just make sure your firewall 1 become the active unit once it will online or if it is up and running, guys. So let me just tell you one situation here. Let's suppose I have firewall 1 and I have firewall 2. We are running these firewalls on active passive mode. This is your active unit. This is your passive unit. Now, let's suppose there is a one time. So I'm just writing here time. Let's suppose at 12 p.m. What will happen? Due to any reason, this device is failed or this device is went down due to any reason. So what will happen? Your firewall 2, it will become the active unit, right? And after that, what, when we see the SNMP alert, what we will do? We will do some troubleshooting. And at 12:30, let's suppose 12:30 p.m., this device came online. So when this device came online, what it will do? It will become the passive unit initially. And this device keeps acting as an active device. And what will do? Now this device keeps acting as a passive and this device keeps acting as an active device. If you will enable the preemption, guys, means this is the case where preemption is not enabled. If preemption is enabled, so what will happen? At 12:30, your firewall 1, it will become the passive device and it will wait till 60 seconds. This is the preemption hold time. Preemption hold time. It will wait till 60 minutes and will become the active unit again. And this device become the passive unit. So your preemption, what it will do, it will always make sure your active unit will be in active unit, always be in active mode. If it is up and running, guys, this is your preemption. Now, in active design, what are the use case, or basically what are the deployment method we are having for active unit, guys? So your active deployment method is, let me just write down few methods here. So the first active deployment is known as floating IP deployment. Floating IP deployment. This is the one of the method. It's ing here. Floating IP deployment. The second deployment method is your ARP load share deployment. ARP load share deployment. Your third active deployment method is your mixed mode deployment. In mixed mode deployment, what will happen? We can use on our WAN side. On our WAN side, we can go with the floating IP deployment. At your LAN side, we can go with the ARP load share method. And the fourth deployment is when we have a asymmetric routing environment. So these are the four use case of your active deployment method. Generally, guys, you will see your active deployment in this scenario is only where we have a asymmetry in our environment. Okay. So these are the four use case of your active design, guys. Now, what is the heartbeat message and hello message? So I think I have already discussed these messages in detail, right? Your heartbeat messages is used for conveying the state of each other, and we will exchange these heartbeat messages to check the liveliness of your peer. Means your peer is live or not. We will use this method to check the health of your other peer. These are the kernel level pings, guys, and these pings we will exchange through HA1 interface, your HA1 backup interface, and your management interface as well, if we have enabled the heartbeat backup through management interface. Hello messages is also exchanged between firewall 1 and firewall 2, guys. And these hello messages we will exchange where they will basically tells about the config sync details, right? All these kind of information is included into your hello messages, your dynamic updates, versions, right? Your PAN-OS versions, all these details they will exchange through the heartbeat message, hello messages, guys. Okay, so these are the 10 questions, guys, which I want to cover with regards to today's session. In your next session, I will cover what are the ports we need to allow in a firewall if it is in middle. What are the prerequisites for firewalls if we want to configure them on a HA pair? What is session owner and session setup in active unit? What are the daemons involved in Palo Alto Firewall HA? What are the HA states we are having? What is the link monitoring and path monitoring? What is Palo Alto? So we will discuss Palo Alto advanced architecture diagram also for HA, guys. What is HA agent? What is pen DHA daemon, right? We will discuss regarding that as well. How we can upgrade the devices if we are running on HA. What is the role of system daemon in your high availability? So these are the some tech related interview questions, guys. Okay. And we will also share you one Google form, guys, where what are the questions you have faced in your interview with regards to Palo Alto, you can also write these questions. So we will also start picking these questions and we will start explaining them, guys. Now, this particular session recording you will get into our portal, which is already mentioned by Vidit sir. So let me just open that portal for a minute, guys. So here you will get these particular recordings, and I am going to upload this particular recording inside. You will have a one course with the name of Palo Alto 5 interview question and answers. Here you will get all the questions. Here I have already uploaded my last class where I have explained how you can troubleshoot the Palo Alto firewall issues using global counters, your packet captures, packet filters, and flow basics. So here you will get how your tech pupils or any professional troubleshooting you can do on your Palo Alto firewall. So you can refer that video, guys. Thank you, guys.